Hello, guys. So this one is about learning, right? So we have been doing this TDD stuff since 2007, and in training people to do TDD since 2009. And the last 2 years, I've been trying to introduce the code katas into my organization. This is from the code kata sessions, what have I learned? And so in learning in general, what have I learned from it? So this is a photo from our code kata. I see some smiles in the audience. You're there. So I'm Marcello, _MD on Twitter. I contribute to a tool called PHP Spec, and I work as head of training at a company called Invika. This is where we do the sessions code kata. If you don't know code katas, kata is a fancy Japanese word that basically means form. Form because repetition of movements. This comes from martial arts. So when you're a little kid, if you did like karate or stuff, anyone did? I did. I don't know much karate now, but it was like white belt or something. But we had to repeat some movements until you learn the sequences of movies. Oh, at least you have seen that movie, the Karate Kid and stuff. Keeps repeating the same movements, and then when it's actually go to a real life situation, he gets like, show me how to walk the car, and it's the same idea with the kata. You repeat the same series of movements. In this case, is keyboard movements, and then this idea of movement imprints the forms into your subconscious, so it becomes easy for you to react with those movements in a real-life situation. That's the idea of katas. So this is all in a context. A part of learning is practice. And someone said to me, it's not practice that makes perfect. It's perfect practice that makes perfect. Do you have that saying in English? No, but some language they do. So it makes sense to me. It's not just, you're practicing something. If you go to work on a daily basis and you're doing your job I've seen developers, they present me curriculums, say, I've been doing programming for 15 years. And wow, let's get this guy in, let's interview him. And it's absolutely horrendous. So he's been doing this work on a day-to-day basis for 15 years, and he's completely crap at his craft. So it's not practice that makes you a better developer, or anything. You have to practice in a particular way. So there's this thing called deliberate practice. Have you heard of deliberate practice? Yes? So you practice something deliberately, and what you're doing there in that practice, you're not going to use for anything. So it's a throwaway task. You practice something, and then you throw in a bin, you delete everything at the end of it, and you practice merely for the sake of getting better at what you do, right? So if you play the guitar, I play the guitar a little bit, so you're learning something new. My son is learning the Police, that the song that the Police, that message in a bottle. So he's learning the riff in the guitar. He's suffering so much with it. He was all excited in the beginning when he started playing it. Oh, this is awesome. But then he could never get to the end, so he gets frustrated. And, but then once you become good at it, then you feel, wow, I can do this. It's good. So you feel rewarded. But that's, that practice is a throwaway. You're just repeating the thing. You don't even want to do it anymore. I want to do something else. I'm going to play Mario Bros or something. So that's a deliberate practice. So we do katas. Katas is a little bit, it falls into the category of deliberate practice. And in a code, you do it for 20 minutes. That's kind of 20 minutes practice. You have this 20 minutes time box where you're going to work on a problem. And at the end of the 20 minutes, I tell the developers, now take your hands off the keyboard and delete your code. And they go with their heads and delete the code. No, you can touch stuff with the hands and delete the code. And some developers get really pissed off. They have to delete the code. Oh, I've been working for 20 minutes. I want to continue working on it in the next 20 minutes. No, you start from scratch again. And the idea is that you're not really trying to solve the problem. You are practicing something in that 20 minutes. And that's something that you're practicing. Is not really how to create a string calculator or how to convert Roman numbers, or it's not that. You're practicing the TDD rules and you're practicing the refactoring rules. So that is this test code refactor, which I believe everyone's familiar with, the triangle. So the 3DD rules that we say, now we're going to start at the 20-minute section, and in these 20 minutes, you're not allowed to write any code that is not preceded by a test. You're not allowed to do that. The next 20 minutes, you're not allowed to suck. You can suck at work, but in this 20 minutes here, you're going to write a test first. The goal here is not to solve the problem. The goal here is to practice this. And then you're going to write just enough tests to get a red, a failure. And once you do that, then you're allowed to write code, but just enough to get a green stage, and then you have to refactor. But the TDD rules doesn't say anything about refactor. There's nothing about refactoring here, right? That's only about the test phase, which is no code without test and just enough to get red. So these are related to the test stage. And to the code stage, you have just enough to get a green. So if you look at the TDD rules and you get people to start practicing TDD with the TDD rules, they start getting into some bad habits. If you just give them the TDD rules, which is they do not refactor. Anybody not familiar with the ping pong model of pair programming? Yeah? So it's very competitive. So you put the two developers to work together on a problem, and you say, once you get to the failing test, you're allowed to give the keyboard to the other guy. So the guy gets a failing test, and he gives the keyboard to the other guy who has to make the test pass, and then write another test and give back to the other developer. So that's cool, but then they stop refactoring because they get very competitive. I just want to give the keyboard to the other guy and make it pass, and write another test, give to the other guy. What's the refactoring? It's no refactoring. So after a while, the code is just growing, and but it's not in my hands anymore. It's in his hands. So I don't care. It doesn't really help. So we did ping pong sometimes and had the rule: if the guy that you're passing the keyboard to is not happy with the level of refactoring, the current level of refactoring, he can complain and say he doesn't want the keyboard until it's refactored. So we add that into the ping pong problem. If they want to do ping pong, they can do ping pong, but they have to use this rule. Does that make sense? Okay. And then we introduced the 4 rules of simple design. So something was missing, which is the refactoring phase. So Kent Beck talks about the 4 rules of simple design. Yeah, you heard about it? Some heads like this, some of you. So it's basically some rules to regulate refactoring, to guide you what is it that you have to focus next if you're going to refactor your code. First thing you're going to do when you refactor is make sure that all tests are running and passing. Okay? If your code is not covered with tests, there is no refactoring, right? No, not possible to refactor code that is not covered by tests. At the end of chapter 1 of the refactoring book, Martin Fowler says, you should only start this thing once you have a suite of tests covering all your code, and then you can start refactoring. So no refactoring without tests. And then also, this also means that you're not seeing any smells on your tests. You're not seeing your tests expressive, and you don't have many assertions in a test case. You just single assertions, and you look for test smells, and then you look for repetition smells. Repetition smells is don't repeat yourself. Are you missing a concept in your domain? So when you see yourself writing the same code twice, that indicates that you're missing a concept in your domain. You're not capturing it and putting somewhere. And this is the worst sin you can commit when you're writing code. So repetition is the mother of all smells. If you don't capture your concept, if you don't protect your value objects, this will come and hunt you. So that's the first thing you have to do. Don't repeat yourself. If there's any repetition, you capture it and you get rid of it. Next thing you're going to do is make sure that your code is very expressive, right? Remove all opacity. And the fourth rule of simple design is that if you have become too obsessive about refactoring and gone too much down the line, and you created too many classes and too many methods, then you look back at it, and then is there anything I can simplify? And you simplify back. So design is a crazy activity. If you sit next to a guy who's a designer and you're just a junior developer, you're going to go insane, because a senior developer will make a decision today and change his mind tomorrow. And that's absolutely normal if you know your craft. It's okay to change your mind. Yeah, and you only stop refactoring when the last user dies. So it's always as an eternal activity. So one example of a problem that we give is the Roman numerals Kata. So the goal of this Kata is to convert the Arabic number to Roman numeral. So basically, you're given an input like this one, and then you have to output something like that. Okay? So if you follow the TDD rules, you write some tests, make it red, and then make it green, and then make it right. Okay? So I'm going to show to you how to do it wrongly. So some of the patterns. So if you're ever going to speak on a conference, if you haven't yet, what are you going to do when it comes to the demo? You demo something that is supposed to go wrong, then your demo is never going to go wrong, because you demo something that's supposed to go wrong anyway. So, so I'm going to show to you how to mirror the display. So let's go here. I have an empty, can you see what I'm seeing? Yes? You're very quiet today. You're tired. It's been intense 2 days. All right, cool. Is it okay at the back? Can you see it? All right there? Yes? Good. So I'm going to start a code kata. So I'm describing a Roman numeral. So I'm going to start my test. I say PHP spec. Well, actually, this is empty, so I need PHP spec here. So I'm just going to bring PHP spec in. I'm going to say PHP spec, describe a Roman numeral converter. Yeah? It's a good name? Okay, so if I run my test, it says that the class doesn't exist. Create the class, run the test again, and I'm back to green. And I'm going here on my editor, project, and I have this test that's useless. And it's going to create a new one. And what is the first thing it does? So I'm doing this wrongly, okay? So it converts Roman to Arabic to Roman. Okay, I'm going to solve the whole problem in one test. So this convert one. The simplest thing I can think is one. Should return what? 1. Right? If I go back there, run the test, create the method, run the test, and it doesn't pass. Because it's not returning 1, I'm going to solve this problem very quickly. And I'm going to return 1. Yeah? We're done? I can go home. So another test. Converts Arabic. Oh no, I already have that name. So I'm going to do another assertion there, because it's the same thing. If it converts to what? Uncle Bob does that too. He puts all the assertions in the same. Uncle Bob can, I can. So it's red. It says expected to got 1. I know why. Because it says here 1. So if argument is 2, then I'm going to return 2. Right? Good, I'm good to go. It's working. So I stopped for refactoring because the old and wise told me that I should refactor. Let's go. Refactor, rename, and Arabic. Okay. All good. Another one is, what's the next thing? Next logical thing is going to be 3, for sure. Yeah, after 2, 3, right? Makes sense. So 3, I'm going to go again. Oh boy, doesn't work. Come back there. I know how to solve that. If it's a 3, this code, wonderful. And if you ping pong, that's what they do. Just get to green very quickly. Cool, what's the next thing to do? I know. Next thing, oh, 4 is too complicated because it has a V here, and I haven't talked about V yet, so I'm going to do 5. And then when I have the V, I'm going to use for the 4. So I'm going to run again. It's negative, and okay, if I know. Yeah? Equals 5. Then, you see where this is going? And then when you start going back and you start thinking about the algorithm, it gets too light. Raise your hand if you've been there. Yeah. Rabbit hole. Right? And that doesn't work. And then when you try to solve this, and then I'm going to refactor and solve this, and you spend like all the 20 minutes trying to solve that step. Yes? And you cannot go back to writing tests again. Okay, so what's wrong? Why this doesn't work? What's wrong with this? Okay? So I have to go back to my other view. All right, so Uncle Bob, he gave recently a talk on the TPP, the transformation priority premise. He introduced that in 2013, early 2013, but he has been talking about this a lot. So basically, it's introducing a new idea in the TDD steps, which is the coding stage. Okay, so it's very clear that when you're writing your test, it's very clear the steps that you go through. You create a setup, you do your range, and then you do your act, and then you do your assertions, and then in some cases, if you're doing integration tests, you're going to do annihilate. But it's not very clear what you do on the coding stage. And it's also, again, clear what you do in the refactoring. You just follow the refactoring 4 steps. It's very clear, but what do you do in the coding stage? So Uncle Bob talks about transformation. And he said transformation is another force in TDD. So it creates a new force. So as refactor is pushing to design, and transformation is pushing to getting to green. So refactoring is pushing towards stability, continuity, maintainability. And there's this pull from transformation, which is trying to get things done. But not just trying to get things done in any way. Try to get things done in a way that you can progress with the algorithm and get closer to the algorithm rather than get lost in a rabbit hole. Okay? And he compares that to playing golf. I'm laughing because I'm remembering Rob Williams' golf joke. This is the Scottish great golf. So you had to hit the ball with the minimum amount of strikes to get to the hole. It's amazing sport, and you put a small hole around there. There on the other end of the field, and you put some obstacles, and you put some sand, and you put some lake, and you do that one time. No, do it 13 times. You have to spend your day with a small ball trying to hit a small hole, just right across the other side of the world. So, and you have to do that with the minimum amount of strokes, right? So if you hit the ball with one stroke, you get into the hole, that's when you get your points in golf. So here's the same thing. With the transformation, the goal is to get to green with the minimum amount of keystrokes. And Uncle Bob said, you're playing golf. So there are a bunch of transformations you can do to achieve that. Okay, just like there are a bunch of refactoring techniques. You can use extract methods, extract a class, or a bunch of refactoring techniques. You also can think of transformations in a particular way. Now, there is a priority element to transformation. Okay, you're going to start with the simplest transformation and then go to the bigger transformation. And that's the trick, because if you follow this, and sometimes it's not really intuitive, it doesn't make sense, but if you follow this, you see the algorithm starts revealing itself to you. It's very interesting. And there's a reason for that. Uncle Bob does not talk about that, but I was thinking about what he was doing, and it really much reminded me of when I studied calculus at the university, you know, the mathematical induction process. So if it's true for n, then it's true for n plus 1. It's a very similar rationale. So you start with a very simple case. So there's one before this one, which is void to null, or nothing to, and then transform to null. But in PHP it doesn't make any sense, because in PHP all functions that doesn't return anything will return null. So the first transformation for us is to transform null to a constant. And a constant means a value. So you're returning that hard-code value. Like I did in the first test, I returned the I value. So I was not returning anything, and I converted that. I transformed it to return I. So that's the very basic transformation. The next one you do is to constant to a constant plus, so it's a more, it's like a elaborated constant. So it may be an expression. And then you can convert constants to scalars, specific values. In this case, a variable. So you can create a temporary variable within your method, and that's a transformation that will handle value, as you see in a minute. You can also convert a statement to more than one statement, and that's a simpler transformation than creating a guard clause or an if condition. The next thing you're going to do is to convert those series of statements to if conditions. And this is the magic one. When you see yourself converting a condition to a loop, you're really very close to crack on the algorithm. So this week we lost Jim. Anybody knows Jim? Yeah, okay. You're welcome here. All the Ruby guys, you're welcome here. Don't be scared. We don't eat you. So he's from the Ruby community. Many of us, I know I do, use a lot of his tools. He's responsible for Rake, and he was also in a team who creates the Ruby gems. Passed away last week. And he did the coding Kata, which I'm going to show you now, but in the PHP version of the Roman numerals. Okay, so we start with a test. And the first test is from Arabic. So I'm starting from the 0 case. What I'm choosing the 0 case. This is going to return a constant, a very simple constant, and it eliminates a very basic scenario, which is the most simple scenario, which is you're passing 0. And that's just going to give me opportunity to create all the elements that I need in my system. This is also called a walking skeleton. So if you think about a project, this is what you do if you are on the sprint 0 or sprint 1. If you're starting a project, you want your feature to take, you're going to build a small part of a feature, but you want to make sure that all the basic elements of your boundaries are there. Okay? And then you're going to increment on that rather than, how do you call it? It's incremental rather than stacking things on top of each other. You're not going to deliver this bunch of features, then add more features on it. You're going to create a very translucent version of your system and then engross it. Okay, so that's called a walking skeleton. And then you do that for tests as well. You write a test that's going to give you the chance to write all the things that you need to get your system going. So that's walking skeleton. And then you run your test first time, and that's going to tell you the class doesn't exist and the method doesn't exist, and you create that for you. Or if you're using a proper tool, the tool will create that for you. What? And then you look at your class. Of course, your class is empty, and then you have red, which gives you the chance to write code. Red means you're allowed to write code. And then the first transformation comes in. So that you're going to transform the null. The test is saying, hey, we're expecting a value, and you got null. So what's the transformation? Null to constant. Make sense? So that's the first transformation, null to constant. So I'm going to put a value there, and then go back to green. And then my next test is 1 should return 1. And then I run my test, I get red. I transform, and now you're going to see that I have an if clause. Okay? I have introduced an if clause. So that's unconditional to if. Okay? I didn't have anything better to do, so I skipped a few transformations. That was the best thing I could do at this point. I look at that. Okay? I'm thinking now, what's my next test? So I think I'm going to go with 2. So if it returns 2 for 2, I think that's going to help me. I see a pattern here, 1 and 2, they kind of build on each other, could build on each other. But I'm going to start with a very simple, I add another statement there. So I'm going to do a trick here in PHP. I have a string repeat. Okay? So I'm using the number that comes in, and I'm repeating the number as many times as I have eyes. Okay, so I'm converting a statement into another statement, which is a more complex statement. And then I'm going out to the 5. Okay, I don't think I'm going to learn anything with the 3. It's going to give me the same result with the 2. I'm not ready for the 4 yet, so I'm going to go for the 5, which is a simpler case. So if I run that, of course, I get 5 eyes, which is not Roman. And if I look at my code, how I'm going to do that, I'm going to create another if, okay, which is going to look like this. And I feel uncomfortable about it first. And I'm thinking, is there anything I can do about this? Not sure yet. So I can skip the transformation and then keep it and go into 6. I think if I do 6, I can start going in the direction of my algorithm. I have something in my head. So I'll go 6 and get 6 eyes. And that's not quite what I want. So a little bit of refactoring. So that pushes me into the idea that there's something wrong with the design. When you see the repetition on your code, it's time to go back and wear the design hat. And that's when you refactor. Okay? So a time to transform is when you're trying to get to the easiest way to make your test pass. And a time to refactor is when you feel you're struggling choosing your test, and it's time to refactor. When it's hard to write a test, you have to refactor your code. Okay? It's an indicator. So for now, I'm going to just comment out my test number 6, and PHP spec is nice, and say, hey, if you comment your test, I'm going to mark it yellow. You know that, right? I'm not like other tools that are going to make it green. So you get here, I'm going to go to my test now. I'm going to look at the code. How am I going to introduce the 6 here? I'm going to introduce a temporary variable, maybe. And you remember temporary variable is another transformation. So that's very, very useful. So that not only helped me refactor my code, also captures a concept that was missing in my domain, which is the Roman that I'm returning. I put a name into it. It helps me see the different places where it appears. So now if I uncomment my test and run it again, it will pass. And the reason why it will pass is because I am concatenating, or not, rather taking away the 5 and then concatenating with the 6. So let's see. Okay, so yeah, now you're taking away and then you add it to the Roman. Is that right? What was it? No, it's here. There's one wrong order. A bug on the slides. Okay, but the test tells me that I don't have a bug, so I don't care what you say. Okay, so now I'm going to go for 10. So I go to 10, and I copy-paste the 5 and the 10, and this copy-paste is really useful. Why is it useful? What? Sorry? Because, yes, it tells me that there's something going on here. There's a pattern. And if there is a pattern here, I can think if the pattern applies to everything. Okay? And when you see a pattern happening, what you have to do next is to try and see if you can convert conditions into loops. Okay? And that's exactly what's going to happen here. How can I convert that condition there, the top one, into a loop? What is the next test that I have to write? Anyone? The first, line 9 to line 12. 20. Yes? Okay. So I'm going to write one for 20, and I run the test, and it doesn't pass. So I look at the if, and I just convert that into a while. And this is a great indicator that I'm in the right track of my algorithm. Okay, look at that. It's the same code. I just convert that into a while. And then now, out of magic, it passes. Okay? And then I have to add another condition. So I'm going to add, now I think I'm ready for 4 now. 4 doesn't pass. And I go look at my code, and I add a copy-paste for the 4. But you can see the same pattern passes, so I just put whiles everywhere, and it works. And I look at the last bit of code here. Can I convert that into the same while? I could, right? Can you see that? So it's still passing. I look at the last bit. I convert that into a while as well, the same way. You see what's going on here? You're really there with the algorithm. So it passes. So what I'm going to do, I'm going to get the first while, put into a for each, and the for each is going to go through the configuration, which has my magic numbers. So at the moment, I just extracted 1, which is the 10 case, just to see if it works. And it works. So I'm just going to do for all of them and remove all the repetition. Okay? And it still passes. And now I just want to make sure, because I'm a bit obsessive, if you just create a test with a crazy number to see if it works. And just put everything there. And then if it works, I'm done. And so that's the kata bit. So if you do this for a while, what's going to happen is that in your team, some people are going to say, oh, not the Roman numerals again. Not the string calculators again. Let's do something new. Not all this thing, the same week, the same thing. And people going, so you're going to find some resistance. And it is okay to create variety in what you're doing. We're now doing something with a big number. We have a problem now that we're solving now for the last 3 weeks or something that we haven't got to the end yet, which is a problem. You have to have a very massive number, and you have to add loads of massive numbers. And at the end, the result of the massive numbers, you get the first 10 numbers and display the result. So of course, the goal is not to solve the problem, but just the thinking head that we have now, applying TDD, has completely shifted, because we're not trying to solve the problem anymore and creating new interesting problems for us. And Dan North, he talked about katas and deliberate practice. And he was criticizing it, saying that, what's the point of doing code kata? Code kata is something that you do is a repetition thing. And if you learn something through repetition, it's because you are in a very predictive environment. Okay? So he says that if you're doing katas and deliberate practice, you are optimizing for performance. It's like a guitar guy. He's performing practicing the same solo, it's because he's going to play the same solo when he goes live. But we, as developers, if you're doing the same thing every day, you should quit your job, find another company to work for, because that's something wrong. You don't do the same problems every day, right? So if deliberate practice is for optimizing for performance and maximizing variance, minimizing variance. So things that work the same way, you just practice, 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 and you'll be able to control that much better. And then he introduces something else. He's suggesting that better than deliberate practice, it will be something like deliberate learning. He says, don't worry, guys, you can still use Japanese names. Instead of using kata, you're going to use koan. So koan is a concept from Zen Buddhism, in which the Zen guru will give like a weird puzzle, like what's the sound of a clap with one hand? And then the students are going to start thinking, and then there's the snap idea. So it's practices that optimized for discovery, because that's what we do on a daily basis. You learn new things, you learn about your customers, you learn about your problems, you learn about your domain, you learn about the model. And so this deliberate learning will be optimized for variance, maximizing variance. Okay, so that's an interesting idea. So I talked to them at the Agile on the Beach last year, and I said, you have to be very careful with what you're saying, because you might discourage people from doing deliberate practice. And I think my perception from the last 2 years, it has taken the guys, many people who were in the team who didn't have the chance to practice TDD before, to a level that they are now very comfortable with TDD. So I think it's a very good element of learning the repetition and the katas. I think it's really good for if you haven't done any TDD before, and if you're trying to get into TDD head, it really creates a muscle memory for TDD, and I've seen that. I think it's a good side effect. Of course, if you know TDD, and Kata is good for fun, but you need more than that. Another important thing is that Kata is not going to teach you TDD, okay? You cannot learn TDD in itself. You don't learn TDD just by doing TDD, because TDD is just a way to express design. So learning TDD is learning what TDD can do for you. You have to learn everything that TDD can do for you. If you know about design, if you know about how to achieve this algorithm discovery, all those things, TDD can just make the process flow. It's just a flowing mechanism. It controls the fear and makes everything small and step and incremental. But if you don't know how to design, you won't be able to get benefit out of it. Okay? So you have to learn design before you learn incremental design or emergent design. And TDD is emergent design. So there's a book I'm reading. I'm not reading the German version, but this is the original one. It's called My System by Nimzowitsch. I'm a chess lover. So in this book, Nimzowitsch say that the beauty of a move lies not in its appearance, but in a thought behind it. And if you see Kasparov playing and he does a move like that, and you go, my God, how did he see that? It's just like, I cannot believe. It's a simple move. I would never have thought of it. And he not just thought of it, of course, he knows of it. He understands the theory behind it. He understands what's going on in a chessboard. He has a full awareness of what's going on in the board. He can play without even looking at the board, right? So there's this awareness that we need to develop. We need to be aware, where are we going with this? I understand domain. I understand what I want to achieve with this domain. I know what I'm getting. TDD is great because it just pushes me forward. But if you don't understand what you're trying to get with TDD, TDD is not going to get you anywhere. You do have to learn. So in this book, he talks, first you have to learn the elements of chess. Then you learn the positional play. Okay? So how to gain control of the board. And then last thing is practice. Here's examples. Here's successful play. And then it's loads of plays are his own plays against other players. Okay? So first you have to learn the elements of design. Then you learn how to drive the design with tests. You do have to learn design to be able to use proper TDD. Okay? So we're also hiring. And please try, if you haven't, PHP Spec. And you can follow me on Twitter. And there is also a training course where you can join me to hear more about these topics. It's online. Thank you. And if you have questions, we have some time. Yes?
Hi there. Just wanted to ask a question about the transform aspect.
Yes.
So the way you're talking about it, the test part would be defining the interface and making sure you understand that. So with the transform, would you view that as a rule set for building / adapting the logic to solve the problem?
So that with the transform, you're really trying to adapt the existing code to now satisfy the interface, but with the minimum effort and following a priority list. Simple transformations first, and more complex transformation later. Okay? So it's like, if you think about in the project scale, you also have the same forces. So like Scrum, right? You have the business. So the business says, out, features, more features, out quickly. And then the Scrum Master is saying sustainability, keep the flow, optimize, follow the values, agile values, and don't work extra hours, don't just maintain. And then the team producing. So you have the three elements in TDD as well. Okay? So you have the test, which is hoping for features. Say, please write this feature for me. I want this. And then the transformation is, it's about the work. So it's like the team. So delivering value, but just enough. But then you have to refactor to maintainability, to keep the sustainability of your system. So you have the three forces when you're TDDing. So if a project is going wrong, you can see what are the three dimensions, out of the three dimensions, which one is failing? Is maintainability? Is it business focus? Or is it deliverability? Okay, so the transformation is about delivering in a way that is not going to mess up your work. You're not going to do more than, you're not gold plate. You're not going to do gold plating. Yeah?
I just thought I'd add Uncle Bob's definition of transformation for the last question.
Yeah.
He says that refactoring is changing the structure of the code without changing the behavior,
yeah.
Whereas a transformation is changing the behavior without changing the structure.
Yeah.
So I just thought
good, thanks.
It might help.
Another thing that Uncle Bob says, and then you reminded me, is that when I was playing first with that first kata that I was doing, I was adding conditions to trying and resolve the test. So instead of making my code more generic, I was making my code as vague and abstract as my test was. My test was like repeating, the code was repeating everything that was on the test. So transformation is about generalizing. It's about bringing things together, gluing all the code together. So that's why code coverage is a scam. Code coverage implies that you have to have all the lines of your code tested, and then you're going to write one code for this method and one code for this method, and everyone is 100% tested. But if you're doing it properly, you're going to have 7 tests from one line of code, and every time you add a new test, you decrease the amount of code you have. Okay? That's why code coverage is a scam. You should have many, many tests for just, and the more tests you write, Uncle Bob puts in a very nice way, as your test becomes specific, the code becomes more generic. Right? It's very nice. Anyone else? Other questions? Saeed, next to you.
Simple question. Why do you use a PHP spec, not a PHP unit?
I did write PHP unit for many years. And when I started writing code for contributing for PHP spec, the first thing I did is to convert all tests that were written in PHP-T to PHP unit. So they tested PHP spec with PHP-T just to make a point that, you know, we're better than PHP unit. I said, no, the PHP-T it's not for this. So I converted everything to PHP unit. And once everything was covered with PHP units, my next step was to convert everything to PHP spec. Because I think PHP spec forces me to design my code. And if I try, I can achieve the same things with PHP unit. But PHP spec, it's like my mother-in-law. It's like finding faults in everything I do. and PHP unit is too kind. It lets me write crappy code. And I prefer to have a mother-in-law who makes me a better person. Does that answer your question?
Sorry, I have another question.
Yeah.
So the code you looked, it's kind of like a greenfield project. You know, you're starting from scratch.
Yeah.
But most of us are working with legacy code that's awful because 6 months ago we wrote it ourselves and didn't have a clue. Or somebody else, even worse. So what kind of advice would you give if you're trying to apply these techniques to legacy code that may not have tests?
So if your code that you're working does not have tests, the code that you're working tomorrow will have tests because you can't write code without tests. So the first code that you're going to write tomorrow is going to have a test for the code that you're going to write tomorrow. And as you write features to your application, you're going to add more and more tests. Sometimes that's really hard because it's a part of the application that you rely on a lot, and you're changing that part of the application, and they're kind of very coupled together. And it's very hard to write tests because the way the code was written doesn't let you replace the dependencies. So you're going to work a little bit on refactoring the part that is a pain for you to change so that you'll be able to continue writing the tests for the stuff that you're adding. Okay? But what you don't want to do is to stop everything and tell your project managers, we can't continue with this because we have to refactor everything to write tests. You can if you have resources for that, money for that, but you don't have to. You can just, in my experience, it's always possible to, from where you are, you can start writing tests for the code that you're adding, and then gradually increment to parts of the system that are not properly tested. Okay? Yes? And there's also some parts of the systems that you could do just acceptance tests for. If it's really, really hard to test that part of the system, and you're changing stuff to be able to test that, you can write some bihard tests for that part, and then change. Any more other questions? That's one there.
Hi, going back to your previous comment about PHP unit and PHP spec,
yeah.
Do you have a concrete example of what you said, basically?
Sure.
You know, why it makes your code better?
Yeah, what I said was actually a little bit inaccurate. PHP spec is gentle and kind. It's prophecy which is the bitch. Because prophecy won't let you, for example, if you start, typical scenario is when you have a collaborator inside of your class, and then you're calling methods of the collaborators. So to be able to test that, you have to return a stub of the stub. So prophecy is going to scream and complain about things like that. Or prophecy won't let you test magic methods. Or there's a lot of constraints. So if you try to test something you can do in PHP unit very easily is that you can have a micro integration test inside of a unit test. So I cannot test this. Okay, let's just make a functional test. Or let's just change from outside, a small black box. And then you instantiate all the classes in your tests, and you put them in and wire them in, and then you can just assert on the result. Can't do that in PHP spec. You can only test the outputs of the methods of your class. It won't let you, unless it's coming directly from a direct collaborator. So if it hurts the law of the meter, PHP will complain. So it forces you to think about collaborators and what's the right way of wiring up my collaborators in this class. Okay? It would be horrible for you to write good code, bad code with PHP. It would be a horrible experience.
Thank you.
Any other questions? Yeah, there's one here. Yeah.
I've looked at PHP spec before,
Yeah.
and I think I dropped
Just
it
the microphone.
because I've used PHP spec before, and from what I remember, there were at the time a minimum amount of assertion methods or equivalent. There were about 5, I think.
Yeah.
And having a little look at, say, RSpec, for example, in the Ruby, there's a lot more equivalent to go with a similar type of framework. Has that changed since then?
Yeah. So there are 5 families of assertions, and you can use them they have aliases, so you can use the same assertion in different wording to make it easier for you to describe what you're trying to describe. There's also something called a custom matcher. So if something that runs away of the typical scenarios, you can very easily translate them into something that makes sense in your domain by just writing a get matchers, which is a key value. The key is the name of what you're trying to assert, the name of the matcher, and the value is a closure, which actually asserts, and you can pass the value. So it's really rare that I find a situation where I need a matcher that I can't either use from PHP spec or I can't quickly create an inline matcher for. Plus, if you are in a domain that you require different kinds of matchers, it's really easy to extend PHP spec now. There's an extension system, so you can just add matchers to the matcher manager very easily. Okay. Any other questions? No? Okay. Thank you.